Whatever the statement they have given in terms of n, we will convert it into k and we will assume that it is true. We take n is equal to 1, we will apply the result, then we will say whether the result is true for n is equal to 1 value. So if the result is also true for n is equal to k plus 1, my assumption is also true. So if we want one more term to be added, we have to add k plus 1 on both sides. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are starting with the new chapter, that is Principles of Mathematical Induction. So, the contents is proof by mathematical induction. So, how we are going to prove any mathematical statement in terms of mathematical induction? Induction is a process where we will prove any mathematical statements step by step. So, what we do here is, whatever the statement or a mathematical statement they have given, we will take in the form of P of n. We will represent it in the form of P of n. So, where the equation or any numbers will be represented in the form of n. That is, for example, first n natural number is n into n plus 1 by 2. We will verify the statement n into n plus 1 by 2 is true for all the positive integers. So, herely we always prove the for all positive values of n. So, therefore, I will take any mathematical statement as P of n. Then, we will show that the statement is true for P of 1. So, that is, we take n is equal to 1, we will apply the result, then we will say whether the result is true for n is equal to 1 value. Next, we will assume it is true for k values. We will assume whatever the statement they have given in terms of n, we will convert it into k and we will assume that it is true. Next step is, we will take for k plus 1 values. So, when we apply the same result for k plus 1 values, if we will obtain the same statements of n in the form of k plus 1, then we assume that the result is also true for k plus 1. So, therefore, P of k is also true. So, that means if we assume P of k is true, then P of k plus 1 must be true. So, therefore, we will apply these three steps to prove the particular statement is true for all positive integer. So, that is, or this process is called as principle of mathematical induction. So, here we are doing it step by step in terms of process. Then we will conclude the result is the given statement is true for all positive values of n by the method of mathematical induction. So, let's take some mathematical statement and prove by the method of mathematical induction. So, you will get one question as a 5 marks question in your examination compulsorily. So, here the first question we have, prove by the method of mathematical induction that 1 plus 2 plus 3 plus etc. n is equal to n into n plus 1 by 2 for all n belongs to natural number. I said n is purely for positive integers. So, where is positive integers? It can also be treated as natural numbers. So, let us take, I said we will first take the statement as P of n. So, let us take P of n is equal to 1 plus 2 plus 3 plus etc. plus n is equal to n into n plus 1 divided by 2. Next, what we will do? We will check for n is equal to 1. So, put n is equal to 1. So, let's take n is equal to 1. What happens now for P of 1? So, if you want only 1, so here we can take only 1. On the right hand side, you have 1 plus 1 divided by 2, 1, which is 2 divided by 2 cancels. So, we get the right hand side is 1 and the left hand side is also 1. So, therefore, what we conclude? P of 1 is true. Next, we take, let us assume P of n is true for n is equal to k. So suppose we take n is equal to k here, we have to replace the statement by k. So therefore, P of k can be written as 1 plus 2 plus 3 plus etc. The last term we take it as k. And therefore it is k into k plus 1 divided by 2. Let me take it as equation 1. So now we have assumed it is true for n is equal to k. So therefore the statement is in the form of k now. Next what we should do? We should take or we should verify for k plus 1 values. So if we want one more term to be added, we have to add k plus 1 on both sides. So first, let us prove the result is true for n is equal to k plus 1. So to prove the result for n is equal to k plus 1, add k plus 1 on both sides of equation 1. So what is equation 1 we have here? That is 1 plus 2 plus 3 plus etc. k. Add k plus 1 to both sides. So then we get 1 plus 2 plus 3 plus etc. k plus 1. And here it is k into k plus 1 divided by 2 plus k plus 1. Now, if we have written it as 1, 2, 3 till n, we would have taken it as p of n. So if it is 1 plus 2 plus 3 plus etc. k, it is p of k. So therefore, if you have k plus 1, then it is p of k plus 1. So now here, so take k plus 1 as a common factor both sides. Then here you are left with k divided by 2 plus 1. So on solving, you will get k plus 1. This becomes k plus 2 divided by 2. I can write this as k plus 1 plus 1 divided by 2. So clearly you can see the result should be in the form of n plus 1 by 2. So therefore if you have k plus 1, then it should be of the form k plus 1 by 2. So therefore what we can conclude, the result is also true for n is equal to k plus 1. So thus P of n is true for n is equal to k plus 1. So now it is true for n is equal to 1. It is true for n is equal to k plus 1 also. We have assumed it is true for P of k also. So therefore what we conclude, by the method of mathematical induction, P of n is true for all n greater than or equal to 1. That is all positive integer n, or you can write n belongs to n. So therefore we can conclude the given statement is true for all possible values of n. But n must belongs to the set of natural numbers. We'll take one more statement now. We have 1 square plus 2 square plus 3 square plus n square. Then it is n into n plus 1, 2n plus 1 divided by 6. So if you have one term, then it is 1 into 1 plus 1, 2 into 1 plus 1 by 6. If you have two term, it is 1 square plus 2 square, 2 into 2 plus 1, 2 into 2 plus 1 divided by 6. Like that, if you have n square of n terms, it is n into n plus 1, 2n plus 1 divided by 6. So first, let us take it as P of n. So let P of n is equal to 1 square, 2 square, 3 square plus etc. So the last term is n square. N square is equal to n into n plus 1, 2n plus 1 divided by 6 now. Now let us take n is equal to 1. So put n is equal to 1. Then what happens for p of 1? So n is equal to 1 means you have to take only one term. So therefore here it is only 1 square. On the right hand side it is 1 into 1 plus 1, 2 into 1 plus 1 divided by 6. 1 plus 1 is 2, 2 into 1 is 2, 2 plus 1 is 3, 2 3s are 6. So on this side it becomes 6 by 6. So here it is 1 square, which means 1. So 6 by 6 cancels, it is 1. So therefore we are getting 1 is equal to 1. So P of 1 is true. So if we get P of 1 is true, what we can assume? So let us assume the result is true for n is equal to k. If the result is true for n is equal to k, how we can write this equation? P of k is equal to 1 square, 2 square, 3 square plus k square is equal to k into k plus 1, 2k plus 1 divided by 6. So let me take this as equation 1. Now we have assumed it is true, so therefore we have written the equation. Let us prove it for n is equal to k plus 1 values. So let us prove the result is true for n is equal to k plus 1. So to get k plus 1, what we should do? We have to add k plus 1 whole square on both sides, because here it is in the form of squares. So therefore you must add k plus 1 whole square on both sides. So for that, add k plus 1 whole square on both sides of equation 1. So if you add k plus 1 whole square, what happens? 1 square, 2 square, 3 square, etc. You have k square. Along with that, you are adding k plus 1 whole square. On the right hand side, you have k plus 1, 2k plus 1 divided by 6 plus k plus 1 whole square. So let us take k plus 1 as a common factor. So if you take k plus 1 as a common factor here, you are left with k into 2k plus 1 plus k plus 1 divided by 6. On solving this, we get k plus 1. Here you can write it as 2k square plus k plus 6k plus 1 whole divided by 6. So you get it as k plus 1 into 2k square plus 7k plus 1 divided by 6. So here you can split it using the middle term. So it becomes k plus 1 into k plus 2, 2k plus 3 divided by 6. So this is what we get. So it should be in the form of k plus 1 plus 1, 2 into k plus 1 plus 1. So we can write this equation as, we have it in the form of k plus 1, k plus 2, 2k plus 3 whole divided by 6. I can write this as k plus 1. Here I can write it as k plus 1 plus 1. And here you can take 2 as a common factor. 3 can be written as 2 plus 1. So if you take 2 common factor, it is 2 into k plus 1 plus 1. So if you solve this, it is 2k plus 2 plus 1 is plus 3. So whole divided by 6. Now this is in the form of n plus 1, 2 into n plus 1 divided by 6. So therefore what we can conclude? The result is true for n is equal to k plus 1. So if the result is also true for n is equal to k plus 1, my assumption is also true. So therefore, the result is true for all. The result is true for all n belongs to n by the method of mathematical induction. So we have to conclude the statement that we have proved the result by the method of mathematical induction. Next question we have 1 cube plus 2 cube plus 3 cube plus etc. n cube in the form of n into n plus 1 by 2 whole square for all n belongs to n here. So let us take P of n is equal to 1 cube, 2 cube, 3 cube plus etc. plus n cube. So on your right hand side it is n into n plus 1 divided by 2 whole square. So let's see now for n is equal to n. So for n is equal to 1, we have 1 cube. There you have 1 into 1 plus 1 divided by 2 whole square. So here 1 cube is 1, 1 plus 2 is 2 square which is 4, 2 square is 4, so we get cancels. So we are getting 1 is equal to 1. So therefore, P of 1 is true. So next what we should take, assume P of k is true. So if P of k is true, how we should write the statement? We have to write P of k is equal to 1 cube plus 2 cube plus 3 cube plus etc. plus k cube you have to take is equal to k into k plus 1 divided by 2 whole square. Now, here we have taken that P of k is true. So let me take this as equation 1. Now let us prove the result for n is equal to k plus 1. So let us prove for n is equal to k plus 1. So if we want to prove n is equal to k plus 1, then this statement must contain k plus 1 whole cube on both sides. So if this is k cube, then we can write here. So if you want to add one more term, then it should be k plus 1 whole cube. So for that, add k plus 1 whole cube on both sides of equation 1. So what happens? 1 cube, 2 cube, 3 cube plus etc. k cube plus k plus 1 whole cube. So that is equal to k into k plus 1 divided by 2 whole square plus k plus 1 whole cube. First let us write this as k square, k plus 1 whole square divided by 4 k plus 1 whole cube. So we can take k plus 1 whole square as a common factor. Then it becomes k square divided by 4 plus k plus 1. So we get k plus 1 whole square. Here it becomes k square plus 4k plus 4 divided by 4. So clearly this is k plus 2 whole square. So therefore, I can write the equation as k plus 1 whole square, k plus 2 whole square divided by 4. If you want to take outside, then this is k plus 1, k plus 2 divided by 2 whole square. Let's check, we can write it in the form of n into n plus 1 by 2 whole square. So if this is in the form of n, then the second one in the form of n plus 1. So divided by 2 whole square. So we are getting k plus 1 also as k plus 1 into k plus 1 plus 1 divided by 2 whole square. Hence, what we can conclude? P of k plus 1 is true. So P of 1 is true, P of k we have assumed it as true. So therefore we got P of k plus 1 is also true. So therefore what we can conclude, P of n is true for all values of n by the method of, by the method of mathematical induction. So this is how we have to conclude the statement, that we have proved the statement using the mathematical induction. Next we have 1 into 2, 2 into 3, n into n plus 1. So n plus 1, n by 2 divided by 3 for all n belongs to n. So clearly take P of n is equal to 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. plus n into n plus 1, which is n into n plus 1, n plus 2 divided by 3. So put n is equal to 1 on both sides. Put n is equal to 1. Then P of 1. So if you put n is equal to 1, here it is 1, 1 plus 1. There it is 1, 1 plus 1, 1 plus 2 divided by 3. So 1 into 1 plus 1 is 2, 2 into 1 is 2. Here it is 1 plus 2 is 3, 3 get cancelled. So 1 plus 1 we get. So we got 2 is equal to 2. So therefore, P of 1 is true. Assume P of k is true. P of k is true means then P of k is 1 into 2 plus 2 into 3 plus 3 into 4 plus etc. n into n plus 1. So in the place of n, just replace with k. So here we have to write k. So that is equal to k into k plus 1, k plus 2 divided by 3. Now let us prove the result for k plus 1 value. So let us prove for n is equal to k plus 1. So if you take this as equation 1. So if you want the result in the form of k plus 1, so here you have to add one more extra value. So if this is k into k plus 1, the next term is k plus 1 into k plus 2. So that you have to add k plus 1, k plus 2 on both sides. So add k plus 1, k plus 2 on both sides of equation 1. So what happens? 1 into 2 plus 2 into 3 plus etc. K into k plus 1 is already there. We have to take one more term, that is k plus 1. K plus 1 becomes k plus 2. And on your right hand side you have k plus 1, k plus 2 divided by 3. So add k plus 1, k plus 2. Clearly you can see you can take k plus 1 and k plus 2 outside. So if you take k plus 1, k plus 2 outside, you will get k by 3 plus 1. So it is k plus 1, k plus 2, k plus 3 divided by 3. I can write this as k plus 1, k plus 2 as k plus 1 plus 1 and this as k plus 1 plus 2 whole divided by 3. Now the statement is in the form of n plus 1, n plus 2. In the place of n you have k plus 1. So thus P of k plus 1 is true. So therefore P of k plus 1 is true. So therefore P of n is true for all natural numbers by the method of mathematical induction. So this is how we can conclude the given statement. So next we have 1 plus 1 plus 2, 1 by 1 plus 2 plus 3, etc. 1 divided by 1 plus 2 plus 3 plus n is equal to 2n divided by n plus 1. So now let us take this as P of n. 1 by 1 plus 2, plus etc. 1 divided by 1 plus 2 plus etc. n is equal to 2n divided by n plus 1. So put n is equal to 1. If you put n is equal to 1 on left hand side and right hand side, then here it is, put n is equal to 1 means it is clearly 1 divided by 1. Here it is 2 into 1 divided by 1 plus 1. So it is 1, 2 by 2 is again 1. So P of 1 is true. So next process is assume P of k is true. After assuming P of k is true, express the statement in the form of k. 1 by 1 plus 2, 1 by 1 plus 2 plus 3 plus etc. plus 1 divided by 1 plus 2 plus 3 plus etc. plus k is equal to 2k divided by k plus 1. So now you observe here, if you have 1 plus 2 plus 3 plus etc. k here, then it is k plus 1 here. It is 2k by k plus 1. So if you want to add one term extra, then you should add 1 divided by 1 plus 2 plus 3 plus etc. until k plus 1. So the equation becomes 2k divided by k plus 1 into k plus 2. So clearly 1 plus 2 plus 3, the sum of first n natural number is n into n plus 1 divided by 2. So if it is n plus 1, 1 plus 2 etc. n plus 1, then it is n plus 1 into n plus 2 divided by 2. If you take the reciprocal, it is 1 divided by 1 plus 2 plus etc. The last term is n plus 1. Then it is 2 divided by n plus 1, n plus 2. So what you want to add on both sides? You want to add 1 divided by 1 plus 2 plus 3 plus k on both sides to prove the result for k plus 1. So let us prove for n is equal to k plus 1. So to prove the result for k plus 1, we need to add 1 divided by 1 plus 2 plus 3 plus etc. k plus 1 on both sides. So let us add it. Add 1 divided by 1 plus 2 plus etc. k plus 1 on both sides. So if you added both sides, then it becomes 1 divided by 1 plus 2, 1 divided by 1 plus 2 plus 3 plus etc. 1 divided by 1 plus 2 plus etc. plus k plus 1 divided by 1 plus 2 plus 3 plus k plus 1. So this is, so for the right hand side it becomes 2k divided by k plus 1 plus 1 divided by 1 plus 2 plus etc. plus k into k plus 1. I have already showed you that 1 divided by 1 plus 2 plus n plus 1 can be written in the form of 2 by n plus 1 n plus 2 because it is purely the reciprocal of first n plus 1 natural numbers. So therefore I can replace it by 2k k plus 1 2 divided by k plus 1 k plus 2. I can take 2 divided by k plus 1 as a common factor. Then it is k plus 1 divided by k plus 2. So which becomes k square plus 2k plus 2 divided by k plus 1. So that is equal to 2 divided by k plus 1. Here it becomes k square plus 2k plus 1 divided by k plus 2. So clearly this is k plus 1 whole square. It is in the form of a square plus 2ab plus b square. So it is a plus b whole square form, k plus 1, k plus 2. So k plus 1 get cancels. So we are left with 2 into k plus 1 divided by k plus 2. So the summation must be in the form of 2n divided by n plus 1. So if you have n here, it is n plus 1. So if you have k plus 1, then it must be of the form k plus 1 plus 1. Yes, this is in the form of the mathematical statement given. So therefore, P of k plus 1 is true. Hence, what we can conclude? P of n is true for all natural numbers by the method of mathematical induction. So hence we can conclude the statement using the principle of mathematical induction. We'll take few more statements to prove by the mathematical induction method in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.